Okay, today I will talk about clause in Houdini, and I will cover uh, main parameters which it has and what it allows to do. And in the end of the lecture, we'll build something like this. So this is a simple simulation where I have a ground object, clause object, and RBD object, which is constrained to the sphere. So it creates such type of simulation. So I have like a lifting force, which is pulling it up. And this works like a little aerostat or something like this. Okay, so let's get started. And first we need to create a new scene. Nothing is here. And first of all, let's create, okay, let's say a sphere. Okay. Lift it up a bit. Okay, and here on the top we have a clause tab, or you can put it here by clicking on plus button and the shelves and then clause here. It doesn't matter, they are the same. I just like it to have here more, and yeah, so it's a bit more comfortable. Okay, so I have a sphere, and let's select this and click on the clause object, and let's play. Well, it's falling down, which is correct, because there is no object to collide with. So I need to create a ground plane from rigid bodies. And currently I have an issue with my graphic driver, so sometimes objects is not showing up immediately. Okay, but now it works. And okay, let's play. And this is not colliding, which is correct, because to make cloth simulation work, the initial object, sphere in our case, must be a polygon. While, as you know, Houdini by default creates a primitive, not the polygon. Okay, so I need to go to sphere object, select my sphere, and in primitive type, I need to change primitive to polygon, like so. Okay, let's play it one more time. And now we see that sphere is falling down, bends, and simulation is working. Well, currently the resolution of the mesh is really low, so simulation is a bit rough. So I can select my sphere and increase frequency, let's say 4. So you see the sphere become um, subdivided. And if I play animation now, it's falling down, and you see that currently clause is really soft. Okay. All right, and let's talk about parameters of the clause. And you can find all of them in Autodop Network, so let's dive inside. And here we have ground plane, which is familiar. I will put it like this. Ground plane, and here is new stuff. So we have sphere object, which is converted to clause. Merge node is for merging few different class objects to be simulated by one solver. Okay, and this is a solver where we have substeps and the fracturing accuracy and the spatial scale, which is basically say never change this value directly. So that should be enough for now. Okay, and that's basically a place where we can control the precision and quality of simulation. Now it stands as float 64-bit, which allows us to get really precise values of the calculation, and this is definitely slower. And if I set to 32 bits, I will get more errors in simulation, but this will be faster. Well, sometimes if you're sure that nothing really important happens to your cloth, you can leave it as 32, but it should be fine to have 64. All right, so let's select the sphere object. And here we have a few parameters. And actually the class simulation was changed a bit from previous version of Houdini, and now it's become weaker, which is not strange, but the side effects, they rebuilding the system, so currently a few features are missing, really important features, but that should be enough for us. And they're trying to make it like easier to use. Okay, so first we have model, geometry, collision, drag, visualization, and creation. So let's start from model. Here we have overall stiffness. This is like main stiffness for the object. And what stiffness actually do? So if I play animation now, you see that it's falling down and bends like this. If I set my stiffness to lower value, let's say 10, and play it, you see that the claws become really soft and just falling down. While if I set my stiffness to a high value, yeah, my interface has changed, so I will reset it a bit. Okay, and okay, I have a stiffness on a high value, so let's play it. And now you see that it's just bouncing and bending not so much. So maybe I need to increase it even more, like this. Well, okay, now it's almost like a rubber sphere. Okay, I will bring it to default value, like this. Overall damping ratio is a multiplier for damping, and damping is basically like a gradient, which will tell how much the force will spread across the geometry. So if I set to high value and play, you see that it's falling down but really slowly because the force from collision is going through geometry really slowly. So if I do something like this, okay, and if I set it to low value, you see that, well, it's possible to see it even here. It's stretching. So overall damping ratio is a multiplier for damping. Surface mass density is also a multiplier. So here all three of them are like global multipliers for the object. And if I set mass density to 1, this will fall like this because the object become really, really heavy. All right. And the cool thing about class that almost any parameter can be edited on the fly, so I can check which parameters I need. So you see, it's really cool. Okay, one really important thing is that class shouldn't intersect with other objects or other class before simulation has been started. So you see the black areas here, it means that class is intersecting with each other, and this can cause a mathematical problem. And to fix this, here is in collision tab, collide with self, and let's increase a bit thickness. I will describe it better in a moment. So you see the simulation becomes slower, but now it's not collapsing with each other. All right, so let's get back to model tab. I will set mass to default and stiffness to default. So now it works like this. Maybe a bit smaller. All right, relative stiffness is next parameter, and here we can control stretch, shear, weak band, and strong band. So stretch is controlling the stretchiness of the material. Shear controls how, I don't know how to describe this. Uh, so for example, if I have grid, oops, okay, something like this. Right, and well, here is problems. Um, okay, I will create a transform node for, no, I will create a group. Okay, and then I will create transform to this group so I can show it to you. So that's a shear when it moves in one plane, but just like this. Okay, and let's go back. And there is two different model of bending. The weak band vert. Okay, the weak band and strong band doing basically the same, but the difference is that weak band will try to simulate the soft class, for example like silk or something like so, while the strong band will try to simulate really hard materials like rubber or skin or something like this. And you definitely can blend them to get interesting results. And yeah, and relative damping is damping value for each of the channel here. So I can control just stretchness, just shear, and seam angle is for merging two different claws together, like sewing them, stitching. Okay. Yeah, my ground is disappeared. What's wrong? I'll do like, oh, okay, my strong band is corrupted. All right, now it's fine. So That's main parameters of the class, and let's see. Um, let's make overall stiffness really small, like so. And my ground plane is here, but it's not showed up. All right. And my class is not working. Well, all right. I will delete this and create it again. Class. Oh, sure. I somehow I removed the gravity force, so there is no gravity, and therefore it's not falling down. Yeah, fine. Now it's working, and let's bring it to low value, and I will set to some long sequence so we can see it in real time. Alright, so I will play the animation, and if I increase the stretch, you see it's become harder. Well, now it's not working because the class already intersect with itself, and therefore the math can't find the solution. Okay, but now the sphere is really hard, and if I decrease the value, it will fall down like so. Well, and unfortunately it doesn't want to get the previous shape, but probably this can be fixed by increasing the thickness of the class. Alright, we'll see it soon. So, something like this. Alright, and if I increase the relative damping here, so the force from collision going really slow from collision point to top of the sphere. Therefore, it behaves it like this. Alright, the shear is probably will not work on this situation because I need to change the direction of the gravity, for example, just for testing purposes. Okay, and you see that it's sliding, but the shape of the sphere is not changing so much. And if I set shear to low value, you see it's just falling. Okay, so that's how it controls. And now the sphere is just sliding without changing the form. It's like force is not applied to this. Okay, let's bring the gravity to normal direction. And here is a weak band and strong band. And to see this, to check this, I will create a grid like this, for example. We'll convert it to class. And now you see it's falling down and nothing happens because gravity is really even force, and that's why it's so boring and uninteresting. But let's create, yeah, okay, let's activate the sphere object, and let's make it really stiff, like so. And I told you before that it's not allowed to have two objects intersected because now you see um, it's do the math, but something really strange happens here. So I need to either move the sphere or move the grid, but I'll do it like this. All right. So now sphere is falling down and grid is covered up. And you see that simulation of the classes here is really rough because the resolution of the class is really small. And cool thing of Houdini is that you can change the resolution on the fly, or you can change it after you set up the whole simulation. And this is really cool. So something like this. And you see that simulation become really slow. It's not even close to real time, but the quality of the class should be way higher. Okay, and this must be really smooth. Okay, so you see that class here is just holding up, and this is not falling down like this. And whoa. Okay, let's see what will happen. By some reason, the sphere object is started flying up, like bouncing or something, which is kind of strange because this shouldn't be like this. Maybe I need to increase the substep rate here to fix this, but I will not do it now because this will make the simulation really slow. And I will go back and decrease the resolution of the grid to, let's say, 15 by 15. Okay, and I will change the uh, weak band and strong band. So let's say I will set weak band to 600. So you see that shape of the class is staying like so, which is not correct, and I'm really wondering why the sphere is flying away. Alright, I will set shear and stretch to default value and change mass to 1. So now it's even jumping. And now it's not gonna fly away, I believe. So, alright, you see that once I increase the softband, yeah, weak band to uh, non-default value, now it's 600, the sphere is staying like this. Okay, now let's bring it back to default. And let's turn strong band to something like 100. And let's render. Let's play the animation. So, you see now it behaves like a piece of metal or something like this because it's just not bending. Alright. And if I set it to 10, and we'll play the animation. Okay, you see it's bending a bit. And now let's increase the weak band parameter to 6000. Well, the difference isn't huge. Let's decrease the strong band. Well, the main thing about all the simulations is that you need to try different parameters until you find something you like. Okay, I decreased the strong band, and now let's decrease the soft band. The more band value you set, the harder simulation will try to keep the previous shape, the initial shape. So now I have a weak band in 0 and strong band in 0.4, and you see that the grid becomes soft, but not really. Alright, and if I set everything to 0, the class will be really soft. Like this. And this will look really great if I would have more resolution here, but I believe you get the idea. Yeah, something like this. Alright, let's revert it to default. Next, geometry. This, I haven't used this tab actually, and let's skip it. Okay, collision. Here we have a few important parameters, and the first three of them are really self-describing, and it's activating the collision with different objects in different solvers. And collide with self, if I turn it off for the grid and play the animation, this will, okay, not now, but if I set weak band to 0, this will basically collapsing with each other. So you see the geometry here is going through geometry, which is not correct. So normally they collide with self should be on. Okay, cloth thickness and contact friction. It's also self-describing, and you can read a bit more if you hold mouse over here. But the thickness is, let's say, I will make this really strong. And let's play the animation. Oops. Okay, and I will make it even stronger because I need it to be absolutely perfect. Okay, now there is no collision and geometry not coming through, but sometimes it might happen that little piece of sphere is coming through the grid, and in that case I would need to increase the thickness of my geometry. The thickness here is basically like a little proxy uh, which is colliding with a sphere. So you see here is a little gap, and if I set thickness even smaller, okay, all right, this is not working, but sometimes it's just overlapping. And to see the current thickness, we need to go to visualization, and here we have a checkbox called thickness, which must show me the thickness of the object. It's not doing it for me. I believe this is the issue with my graphic card. Oh no, okay, it's working here. So here, by controlling the cloth thickness, I can set the proxy. So not actual geometry will collide, but this blue one. And this can help me to solve issues with penetrating. I wonder why it's not showing it to me here. Thickness, oh yeah, okay, my fault. The thickness was really small. Alright, yeah, something like this. So if I set my geometry to my class to something really thick and play the simulation, I actually need to move the sphere a bit down, like so. And if I play it, let's turn off thickness here. So you see that my geometry collides, like it's really thick. So like this. And contact friction, if I set it to, let's say, to 0, and let's offset my grid a bit to this side. So now it's sliding down because there is no friction between them. And if I set friction to really high value, this probably will stick. So yeah, you see the funky things are happening here. It's like it's trying to stick, but the values are really strange. So yeah, so any value should be reasonable, and yeah, so you see it behaves a bit different. All right, and drag force, the dragging, is basically how the object behaves in the air. So currently I have normal drag, tangent drag, and the velocity field. So if I start my simulation now, the grid is falling down like this, and it's like soft falling. It's falling down really softly, and now it's falling down faster. It's basically controlling like density of the air, and now the air will be really dense and almost like water. So yeah, you see it's like underwater. If I increase tangent drag, this will work on some collision, I believe. Okay, I need to make it soft. So you see it's like bouncing here, and if I set tangent drag to 0, this bounce even more, so it's like the decreasing of the force become really slow. Alright, and here is simple parameters which called external velocity field, so you can control it or replace it by creating your own velocity. And external velocity offset, so I can set some value here, and my cloth will move up. Even if we have it here, this is not recommended way to apply some velocity to here unless you use val field. Alright, so I bring it to default. And the recommended way to control it is to create a wind force and put it before right after the grid object, for example. And I will scale the force a bit. So you see there is a bit of velocity, and the force is really weak. Like so. So yeah, now the wind force is applied, but it's really weak. Okay, here we can apply a noise or turbulence. Let's say something like so, really extreme values. And if I play it now, yeah, it was a really extreme values. Let's bring it to default, and I'll set seed and increase a bit wind. So here is the different noise patterns you can apply to wind force. And I think you need to have really high res class to be able to see the difference and get something from this. Okay. And here is not much to talk about in the solver. So if, for example, your class behaves not really accurate, you can increase substep rate, say 8, and your simulation will be way more accurate, but this will also take way more time to simulate each frame. And yeah, global max collision, local collisions, it's all about controlling the behavior, not behavior, but the accuracy of behavior. Okay, now let's create a new scene, and let's talk about constraints of the cloth. I will create a new grid again, and I will convert it to class. Alright, it's falling down. But what if I need to create a curtain or something like this, which is directed down and constrained to guardian or something like this? Well, that's pretty easy here in the Houdini. And what you need to do is to go to wires. I have no idea why it's called wires, if it should be like constraints or something, but there is a wire deformer object, so maybe because of this. Okay, and here we have wire pin constraint. So I click on this, and it asked me about select dynamic points for wire pin constraint. So I will select, for example, these 2 points and hit enter. All right, and I got this spheres. And in Autodapt network, it creates SBD pin constraint 1 node, where I can set the constraint object and the constraint points. And there is a way how to get numbers of these vertices or points. So I click on this button and it gives me a number of each point. So uh, 40, 90, probably there is two points in one. And yeah, and here is 2, 0. 0, 1, 2, 3, yeah, 90, 91, 92. Yep, because it's 89 here. Yeah, I have no idea why it stands 40 here, but probably from the spheres. All right. So if I play the simulation now, you see that the class is constrained here and falling down. I will decrease the drag, normal drag, because it's falling too slow. And yeah, something like this. And I will make the timeline bigger, like this. All right, so I will show the stretch and the shear weak band, strong band again on this result. So just because this will probably give more understanding of how it works. So yeah, the overall stiffness is really weak here. So the class is falling down. Okay. So by controlling the parameters, you can find really interesting things. Or you can make absolutely perfect square here by increasing values a lot. So that allows to think about class object not only as about class, but it can be like RBD. And so yeah, you see. And Houdini Help talks about that it's better to use two class for simulate something than mix class and RBD, because in case of mixing, Houdini have to calculate two different solvers, which will be more complicated and probably will give worse result than if you will have two different objects, but which is controlled by the same solver. Okay,